Okay, hello everybody. So thank you to be here. Today we will work on to show you lots of different use cases and case studies about the new technologies that perhaps you heard today and this week, which is Sirius, which is a new project published inside the Eclipse Foundations. And me, Etienne Juliot, one of the founder of OBO, and Frédéric Madio. We will show you plenty of different use cases in different domains, in train, in electronics, in IT, etc., etc. So, first, Fred, can you explain to everybody what are the difference between some complex system like satellites, like mount system like mobile, and car? What are the common points in the architectural views of all of this?
So the common characteristic between all these kinds of systems is their complexity. Can I get this? Okay. These systems are complex because they need to coordinate many teams, many skills, and many tools to build the system. And classical ways to manage requirements, specifications, or documentations cannot be used on these kinds of systems. So if we consider another kind of complex system, such as a building, see that we need several kinds of viewpoints on the system, and we also need structured data to manage the system. So we need to synchronize both graphical viewpoints and structured data. Graphical viewpoints dedicated to specific skills on the system, specific activities during the building process, or specific steps during the process. And this is very essential to facilitate the communication between the project. Structured data is also very important because it allows you to perform analysis, constraints analysis, performance analysis, and it allows you also to keep traceability between the several layers of your system, traceability between the requirements and the system, and also in some cases to simulate the system before the beginning of the implementation. So if we look at the kinds of tools that you can use on to build this kind of system, complex system, first of all, we can eliminate some tools, classical tools such as PowerPoint or Visio, to provide graphical viewpoints because they don't manage data, the underlying data. It's only presentation. You can also eliminate Excel or specific databases because they don't provide graphical views on this structured data. So you really need to keep in sync both the representation and the data. So you have a solution which can be used on some situations. It's off-the-shelf modeling tools such as UML, SysML, BPMN. You have a lot of modeling tools which exist in the market which are dedicated to a kind of domain. So it can be used if this tool match your domain, your engineering domain. But if you are on a specific engineering domain, this kind of tool will force you to choose a notation, a specific notation, and a specific data structure, a meta model. So, Etienne, what is a good solution?
I have a solution. And if you already know OBO, I think you already know this because it's a DSL. So this is, and of course the other, inside the Eclipse community, there are lots of buzz around DSL, and it's something which is very important, and I will redo your example about building, because when you design something like an aircraft or like a space, I don't know, a satellite, something like this, it's just impossible to find a tools which help you to do this kind of aircraft or this kind of satellite, because the market is not enough large. You need to create your own. And with this, you can create your own with your own language, or own structured data, but also to keep something which is visual, so easy to understand. And usually when I go to lots of different customers, I see on the wall a lot of posters. We show lots of different views that they just do with PowerPoint, and they say, no, I don't need graphical modeling, I don't need modeling at all. But yes, I like this one. It's for very easy to understand my system. So now it's usually an entry point to help them to just to synchronize this different view of their system, and after to use them, help them to leverage the models to connect them to validation or something like this. So you have your own business, your own skills. So your business and your skill is unique. Your designer needs to be unique too, because it's your knowledge which needs to be inside this. And for this, in the Eclipse modeling community, we work for a long time to help you to design some new language, some new editors like xText editors, like a wizard editor already automatically created by generators. But create graphical designers was a complex task, because you need to know very complex API. You need to know deeply the architecture of Graffiti, of GMF, etc. And it's just too complex for classical architect users. So we create, with Thales and OBO contribution, a technology for the last 5 and 6 years that today we publish inside the Eclipse Foundation as an open source project. And we are very proud about this. So why we were proud? We will show you today this kind of real use cases that you can imagine with these technologies. First, let's see some large example.
Yes, some classical examples that we will detail later in the talk. We can give some example. Software architecture to give a large overview of an existing system. Safety, to analyze the security problems on an existing system. Embedded software development, to design an embedded system and to generate a code, for example. Other example, system engineering, to build an aircraft or to design the architecture, electronic architecture or physical architecture. And enterprise architecture, to define an existing IT system and the way the enterprise can manage transformation on this system. So all these examples have been created with Sirius. We'll detail them later, but first of all, I will let Etienne show you how it works with Sirius.
Yep. So first, I will show you what will be the result I want to create. It's a little designer to analyze the behavior of a robot. So I create a little language where you can see some camera here, some CPU, some engine, etc. And you can see that the color and the label change depending of the volume of quantity of information that the CPU can manage. So if I change its value, there is a kind of simulators which propage the temperature in the other elements, and the color change dynamically from this. So it's very easy to see which are the problems of temperatures. So you can after add some fun, and it's become very easy to analyze these kind of systems, which can merge some element of price, of rise, of performance inside a very easy to read diagrams. let's do it. First, we will define the language. For this, we reuse the famous project, EMF, to define the vocabulary or to reuse existing standards. So in our case, we just define some fan with processor, with output, etc., etc. Secondly, we describe the graphical designers with the shape, the style, the change of the style depending of the content of the models, the behavior, all the double click, the layout, everything will be defined by yourself. And you don't need to code. You just have to use here configuration models, which just describe what is these diagrams, what is this element, what will be the color, what is the size of the element depending of the speed of the fan, and everything is interpreted in live by Sirius to produce the designers. So it's very easy and fun to create your own designer by step, by increment. And the result is, of course, an Eclipse plugin, so you can deploy it very easily. And so when you have some user who asks you, oh, I would like to change the designer and to add a new action on this, you can do it in only several hours and give it back to your user. Say, OK, do you agree? So it's very more easy than usually. Of course, everything here is based on GMF runtime. We don't use GMF tools. We see that the designer have been changed without any code generation, deployment, but all the rendering is GMF runtime. And finally, we leverage the model with existing technology to generate code, to validate. So you can use Acceleo, EMF compare, ATM, and others. And for the system architect, so they can specify their own generated code. They can generate documentation. It's usually used for certification or specifications. And you can also, use case very interesting is to reuse existing data from other tools to federate them inside only one repository and to give analysis, overview from cross-domain elements. So you can merge inside the same diagram some elements from the physical, from the electronical, from the software, from the requirement, and everything is the same. And everything is imported every night or in live when you want. So this is an overview of Sirius. There are other talks which explain you step by step how to create your own designer. And this evening there is a buff when you can go with your own meta models, and in only 1 hour you will have your own designers. We promise. But let's go further today. You can, with this technology, you can also add some other features, like see your models through viewpoint. So, for example, if you are an infrastructure expert, you have only a few diagrams, a few informations, which is just filter for your need of infrastructures. You don't see that thing that you don't care about. But you still work on the same models. So for the collaboration, it's quite easy to work with other stakeholders. You can also have some live collaborations. So you can have some distributed team which work together with different views of the same element. And this can be stored with classical CDO models, for example, the database. And there are also some ready-to-use designers, which are open source, which are based on Sirius. For example, you have UML, you have SOA, you have BPMN, etc., etc. So you can use this configuration file, fork them to adapt them to your needs very easily. And for Luna, we will contribute to the new version 2.0 of Ecor tools, a new version of the Ecor designers, based on Sirius. So now let's go to the use cases. So in the real world, how does it work really?
So first example, we have 9 case studies. So we'll try to explain it deeply. So with Thales, Thales has used Sirius to develop a software, a system engineering workbench to work on systems such as an aircraft and to be able to perform early validation of complex architectures.
Of course, when you design an aircraft, as soon as you can change something in the aircraft, it will cost a lot of less money, and it's very important to have very good validation as soon as possible. So they do system subsystems, and they create by themselves their own language and their own graphical environment. So you can see some matrix, some tables, some designers, some complex designers, some easy designers, and everything is driven by their process. So when an engineer starts to work at Thales, he doesn't have the problem of the white papers. He knows that he has to create a new part of the aircraft. He has a first step. He works. It's very easy to create a first system, the input, the output. And after, the tool help him to do the other step in this process of the system engineering. And they do all these kind of designers, so by themselves, because they don't need to patch Sirius by themselves, so it's just worked very well. This is an example, for example, of the video systems in Airbus, when you can see the screen where there is some movies. And this is a kind of use case which is quite complex, because as soon as you change the quality of your screens, there are some impact on the software, on the hardware, on the cable, on the weight of the plane, etc., etc. And it was very useful for them to use this kind of thing. As you can see here, the server which diffuses the video, and here the seat when there is the screen. And by having several layers, they can see some simulation, try another kind of server, another kind of cable, etc., etc.
So this tool can be used to many other engineering domains, such as the thermal problematics or mechanics or other kinds of architecture domains. So another use case. In RIA, which they were working on robots with the problematics of timing constraints, to be able to design a robot to set timing constraints and to verify that these constraints are respected by the robot, the real robot.
You know, a robot has lots of parallel computation for the arm, for the camera, etc. So you need to have some real-time constraint, and it could be very dangerous if it's not well specified. So let's have a look at what they do. Yeah. In this example, we just find a kind of activity diagrams when they add some informations about the timing constraints. It's quite easy to understand, because we will see between the part where they find a way to have the video and the end. They say that it must be executed with only 41 milliseconds. So it's a code, easy to understand, and it will specify timing constraint on this. Here you can have an example of periodicity. So you can say that this element needs to be executed every 40 milliseconds. And this information can be hide for people which doesn't care about performance. So you can add this kind of information, remove them. It's really depend about yours. And after this, they will use all this information to generate code or to change some virtual machine, to create some traces from traces to each part where there are some timing constraints, and they will do some simulations, and they will see with the simulation if the robot is fast enough to have a good reactivity. And doing all this kind of use case of example, it produces traces that they can inject directly inside their design, their models, and so they don't have to go deeply inside the C, the real-time C code to debug or to find where is the problems. We take all the traces, we translate this trace from context which come from the C to something which comes from the models, and we show here directly here that there is no problems on this this constraint because it's 38 millimeters, but sometimes it's go too much to 60 milliseconds. So you can see directly in the design time what was the result of your simulation. And if you want to analyze why there is a problem, you can zoom and see that here there is one thread, another thread, and you can see what was the execution between them. All these kind of diagrams, it's not Sirius which force the semantic of the diagrams. It's just the area which shows that each lifeline correspond to a processor or correspond to a thread. They choose by themselves. And they add also some specific tools directly in the same editors to do some statistic. Sorry. After this, they can change the allocation of functions to some thread and to change, for example, the CPU quality. And they can use it directly, do this kind of thing directly in a modeling environment. Can do so statistic. And if they want to, they have tried to extend this to existing software which was not produced by models. So they take the C code, they apply a reverse engineering engine, and it produces automatically all the models. And from the models produced automatically, they just add timing constraint, they reapply, and it was just easy to understand, whereas the problems of real-time constraints.
Okay, so you have said everything about this use case. So it facilitates the management of timing constraints. So next one, train transportation. Alstom is building TGV, long
High speed
trains, and they have safety constraints, of course. So they have to define all the problems which can occur on this kind of system, and evaluate the consequences of the failure of the train, and so to evaluate if the system is conforms to the safety analysis.
Yep. How do they do this? They have some guys which have strange jobs, just to read all the newspaper of the world. And they find is in each newspaper if there are some accident of train, because there are lots of accidents near than every week. And each time they use their own language to describe what was the context of the train, was it accelerate in station, or what was the consequence, etc. And they did it with Excel. And it works. They do some very good train. But today there are some problems because the guy who do this will be retired in very few years, and they just care about what will happen. So And there is also another problem that during this guy reads the newspaper and do their analysis, the system design of the train continue to evolve, and the life cycle is not aligned. So they have to synchronize the two teams 2 or 3 times per year. It was just impossible because they have to redo all the analysis each time to see that if one part of the system change, which kind of analysis that I have to redo. So with these tools, they want to have parallel process and to keep all the certification that they need to create train. So they create their own language. Of course, they were alone in the world to have this knowledge of accident and risk analysis problems. So they have to create their own. And they reuse a graphical notation that they use usually by paper. Where there is something which is original, you can see here excessive speed and the death of somebody. And to not go to the death, they put some barriers which come directly from the system design. So what we call here CBTC is something which is created by the other teams. So there is a kind of link between the two models to be sure that if I change this analysis, I know that I will change the CBTC element. After they add some layer, a layer which just change the information of the current diagrams to show the risk of each step that you have to you can see. So it's a kind of computation engine specific, which say that here there is less than 99% that this problem can occur. So for the certification, say okay, it's good. But very easily, they can see that in some parts, it's too risky, so they have to change. They can also produce some fault tree. It's forced for them for the certification. And today, it's just produced automatically. This kind of fault tree, you can just analyze from the consequence, what are the reasons which go to this consequence. And they are synchronized and produced automatically. They generate code, documentation, sorry. And there are some facilities to go from this safety analysis and to understand inside the system engineering, which is here done with SysML, what are the functions and the future of this element, CBTC. And after they can change to change the behavior of the communication between the train and the ground, to see that I will change the data input, the data output, the data flow between them, etc., etc.
Okay, so with these tools, they have been able to enter in the tool the knowledge of people who were working with Excel and this kind of tool. So another example, European Space Agency, who works on satellites, and they wanted to reuse more easily some parts of the software and to be able to project existing software to new platform, to new hardware platforms, and to facilitate this reuse. So they have been able to, with Sirius, to develop a tool which allows them to do this.
Yeah, so you can see that they specify the CPU, the memory of the CPU, the performance of the CPU. And after, they can say that this application will go with this CPU, so they can very early know that if it will work or not because of the performance, for example. So for them, it was very interesting. And in their elements, they have they describe the data models, a component models here to describe the flow, and the hardware, and they generate the code here. So if they change the hardware, they don't have to recreate all the code by themselves. They can just reapply the generators, and the code will be generated with the new hardware constraints because it should be very optimized.
So with this, they can reuse more easily existing components and embed these components with new spatial missions. Another example, Maif. Maif is a French insurance company. Of course, they provide products to prevent their customers from any kind of risk, and there are concurrencies on this domain, so they have to permanently invent new kinds of products and to be able to deliver these new kinds of products very rapidly. So, for example, they have delivered a new product to reimburse your travel in case of excessive rain. So this kind of new product, they have to be able to define them very rapidly and to be able to deploy it very rapidly. So
and before we do this with Sirius, it takes them 2 months to just create a new marketing offer, because there are lots of process, integration stage, pre-production, production, etc., etc.
So with this new system, they have developed a product catalog, which is composed of a product repository and product rules with JRules to know how to cost the new product. This catalog is exposed through web services to existing applications for the claim management and the contract management, and the content of the repository, the product repository, it's a model. It's a model which describes the structure of a new product. And this model is edited graphically directly by the experts in insurance to define by themselves the new product.
So your users are really not IT people. They are really mostly office users, and they use EMF for this because it's just for them. It's just as simple as Excel or PowerPoint. So they get good.
Okay, and now with this tool, they can deliver a new product in 1 week. Okay, another example, University of South Brittany, they are working on assistive technology systems to help disabled persons to pilot the equipment in their house. So, for example, the doors, the windows, the lamps, and so on. So this system is configured directly by a model which can be edited with Sirius. So you can see here the system which pilots the equipments, and it is configured graphically with this designer, where you can see the map of the house, and you can define the different areas in the house and which equipment is in this area and how it is connected to the other equipments, and how it is and how it reacts to the different kinds of events. And this model is injected in this assistive technology system to execute and to pilot the house.
And as this is come from the physical design of the building, it's very easy to understand what is the workflow. Now, if you have just a textual syntax, it's just not so easy to understand. That's something with just the map of the building. After this, so you can see that the guy can change, and with only one button can open the light, open the window, open the door, etc. So it needs to be very easy to customize for each kind of houses.
Okay. So it simplifies the design of this and the customization of this configuration of this kind of system. This case study is about producing management applications, IT applications for the Ministry of Defense in France.
So they have several hundred of users, which are developers and functional users. So they need a way to first to discuss with the business person, which not our IT people. So they define a language to just speak about the interaction between the user and the systems. They don't speak about workflow. They just speak about the interaction that I need to fill this kind of information, and the system need to give me this kind of information. So it's very easy. They do this with a kind of brainstorming, a kind of live meeting with a big screen with these tools project on the screen. And after, they apply some user story to say that I will test only this element. So, and it will be injected inside Mylin, something like this, to do some test management. After, the IT teams do create other models to have some more precise definition. For example, the cinematic of the screen and the content of each screen, the SOA and the component and the API of each services, and the entity model, which can create by hand or which can automatically be scaffolded by the schema of an existing database. So you take a database and you produce all of this automatically. And of course, they add some code generators for G2E. The result for this is that they reduce by half the cost of their first project. And for example, for just the entity, they have 80% of the code generated automatically. So it was very good for them on this.
Okay.
So Coregi is a large company which do some we need to have some enterprise architectures because they provide solutions for other company, and it's a company which go very quickly. So they need to understand how they are organized for the company itself and how the information system is organized too.
We have not much time to finish, but just to show you some example of graphical designers. So they can represent the comprehensive situation of an existing system and then zoom and elaborate evolution scenario on some part of the system. They can also define use the tool to perform impact analysis graphically or with a matrix. And it is available through a web client. So last one, it's about logistics. It's a company which provides software to manage the goods within a factory and a warehouse. So they have difficulties to configure this system to each factory, to each customer. So they have defined a graphical representation to define the factories, the warehouses, and the flows of the goods within these factories. And then it configures automatically the system which pilots the move of the goods in the factory.
Before this, it was just XML5, very complex. By having something which is just more visual, they sell more products because it's more sexy.
Okay, this is the last one. So thank you. If you have some questions, I don't know if we have time for questions.
Yep.
So the domain models are EMF models.
Yep.
Again.
Yes.
Yep.
Is there some thoughts about version control, Git, comparing between such kind of things?
Yeah. It's reused. So OBO is also implied inside the eGit and gGit project to be able to manage logical models and the store of models inside Git. So there is a work today which will be released before Christmas, I think so, in the open source project. But it's already works, but it doesn't work on the large project. And for there are also some work on EMF compare, which helps you to do some diff merge on large models and to show the result in the graphical. And it's scaled very well, and there are some information here at Eclipse about this project.
So this is planned for...
Oh, it's work today.
It's here?
Yeah, of course.
Okay, I will be in
It's present in another talk. I don't know if it's yesterday or tomorrow.
But,
Okay, so if you want to know how it works more precisely, there is another talk just after this one. I don't know exactly the hour, where there will be a live demo of the creation of a graphical modeling